So I think we almost have everybody back, so we could probably go ahead and get started here. So this was originally when David and I had done this course, we did it the other way. We did regulations first and analyzers second. We switched it because he had, OGI training this afternoon, so my agenda is a little bit backwards. And then Mark joined us, which was very helpful because neither David and I knew a whole lot about data acquisition systems. So it fit right into the agenda here. So, what we're going to talk about here is why do we use CEMS? What's the regulatory overview? What do you need to look for when installing a CEMS? What is your Appendix F summary? What's your reference methods? What are some of the QA/QC requirements? Your data substitution requirements? And then we've already had the analyzer overview. So why do we use CEMS? They're required by federal and state regulations to monitor the continuous release of emissions to the atmosphere. We already talked about some of the reasons why. So they're driven by NSPSs, NESHAPs, MACs, consent decrees, permit special conditions. So in Texas, which is where the majority of my experience is, any process heater that's greater than 100 million BTU is required to have a CEMS. That's just where they drew the line for Texas, the regulation. There's no regulation that says you shall. It's just TCEQ makes you, if you set a heater at 99 MMBTU per hour, they won't make you put a CEMS. If you cross the line to 100, you got to put a CEMS on it. What about some of the other states? Is anybody else in here is there kind of a written guidance or an unwritten guidance around when? 100 million? Okay. And they're to continuously monitor the emission levels of the control device inlet and or outlet to calculate removal efficiencies is another reason why we use a CEMS. So maybe on inlet outlet to an SCR, something like that, wet gas scrubber on a cat cracker. So here's, I'm not going to spend a lot of time on this. We've talked a lot about the analyzer portion, but there's just an overview of what the system as a whole, broken down looks like. So what's continuous? Who in the room can tell me what continuous is? It's continuous. But the regulation tells us that it's one data point every 15 minutes. So it's not really continuous. I know when I was in industry and when I was in stack testing as well, we always looked at that one data point every 15 minutes, not as a rolling 15 minutes, but as a block 15 minutes. So you're looking at a block hour. So from 0 to 15, 15 to 30, that's such. We'll look at a couple of exercises later at the end of the course too, to kind of help break down, at least how I've looked at it, whether, if you have a different interpretation, we can certainly talk about it and get it out in the room. But that's the way that I've always treated the one data point every 15 minutes is a block 15 minutes. So the elements of CEMS, we've got rules, which have all of our affected sources and purposes and source-specific requirements. And then we've got the performance specs, which that's what tells us, hey, this is what you have to do to show that the CEMS meets the requirements of the federal regs. And then you've got your quality assurance requirements, which are things like your QA manual, your QC procedures, and then anything around an audit procedures. So a CEMS versus a CMS. So the CEMS uses equipment to analyze and provide a continuous monitoring record. And regulations are usually associated with monitoring emissions from the air pollutants such as NOx, CO, SO2, and hydrocarbons. Typically, I would say the most common you see, right, are NOx, CO, and SO2 that you might have to have on a source. They make some ammonia CEMS, they're really finicky. They make some PM CEMS, they're really finicky. So that's the majority of what you see there. And then a lot of times you don't see hydrocarbon sources or hydrocarbon CEMS on sources. You usually come in and run like a method 25 to validate it, and then you use that factor moving forward. And the CMS is a continuous monitoring system, and it's not necessarily associated with emissions. It can include emissions analyzers, and typically there are permit requirements for continuously monitoring emissions for N2O, but it's not a true CEMS. It's not addressed in the CEMS regs and does not have a performance spec. And it can include such things as flow analyzers, content analyzers, and thermocouples. So that's like where my experience in Utah comes in, is that without an FD factor, you can't calculate a flow. So you have to have a flow meter. So that's where it kind of comes in. The whole system is now a CMS or a CERMS. continuous emission rate monitoring system versus just looking at a concentration and converting it to a pound per hour or mass basis. So there are several different methods of monitoring emissions. Some of these include what we talked about this morning. You can do manual sampling, you can do extractive, you can do the dilution, closed coupled, in situ, remote sensing, or the PIMS. The type often depends on what you're looking for. Certain technology does not have to be used, it simply must meet the performance specs. So you can use anybody's technology as long as you can meet the performance specs in Appendix B and Appendix F, the QA procedure. So again, not a lot of time here because we've talked about them. The dry extractive systems are used throughout petrochemical plants, power plants, pulp and paper mills, pretty much all of industry. If you're required to have a CEMS, there are approximately 55% of CEMS measure NOx, or a dry extractive method. It works well at high and low concentrations, but does require frequent maintenance. The dilution extractive equipment has historically been used to comply with Part 75. Is anybody applicable to Part 75 in here? Got two? I'm sorry. We'll talk a little bit about it, and everybody else can feel your pain when we get to the Part 75 requirements because they are a little more in-depth. Common sampling methods continued. You've got your wet and your in situ, which we've talked about this morning. So here's a list of everything that could potentially be monitored by a CEMS system. So SO2, NOx, CO, H2S, total reduced sulfur, mercury, VOCs, opacity, ammonia. And then O2 is a regulated CEMS for the regulations that require correction. So EEE, which is your boiler and industrial furnace, it has a requirement to correct to CO to 7% oxygen. So that's where O2 actually becomes a regulated, it gets pulled in there versus where in the others you have to follow the performance spec, but it's not a regulated constituent. All right, so we'll get into the regulatory overview. So the main drivers behind the need to install a CEMS. So this is by no means an all-inclusive list, but I tried to go through and pick as many as I could that would drive you to have it, which is your Part 60 NSPS, your niche apps, the sewage sludge incinerators in 503 are applicable, the Part 72, 75 acid rain, your MAX. There's a 40 CFR Appendix P existing sources. Your Title V operating permit could lead you to have a CEMS based upon what your requirements are. And then the NOx trading program can drive you to have a CEMS because you've got to know what you're putting out so you can trade, buy, and sell. And then other CEMS installation drivers include a lot of consent decrees required you to put CEMS on. The request variances so the state can come in and say, hey, we want you to put a CEMS on that source, or if you're having a lot of upsets or there's other reasons that they might come in and ask. And then they can also do that through an order, right? So they can come in and tell you that you must put a CEMS on. So what is the NSPSs? So it applies to all sources that are constructed or modified after specific trigger dates. Subpart A is your general provisions. D through Quad O are source-specific standards. Appendix A gives you your source testing reference method, so that's going to be more along lines of your stack testing performance procedures, and then what you're going to do in errata to certify your test comes from the source testing reference methods. Appendix B is the performance specifications and test procedures. This really comes more down to the facility level. So what are you doing? That's Appendix B that qualifies the analyzer, and then Appendix F is the quality assurance requirements, which that's just making sure that everything you're doing in Appendix B is validating the machine. So here's some examples of NSPSs that are required to monitor exhaust gases. You've got DADB, and we've got some DADB applicable people in here. That's one that hits a lot of people. EA, your municipal waste combustors. You've got J and JA, which I'm sure everybody's familiar with. P and Q are your smelters. BB is pulp mills. And then you've got a long list that hit organic emission sources down here. So petroleum refineries. J is applicable to fluid catalytic cracking units, combustion devices, and cloth sulfur recovery greater than 20 long tons per day. and modified or constructed between June 11th, 1973 and June 24th, 2008, which is then when JA kicks in. So it's applicable JA to the same list, but it's fuel gas combustion devices, and they broke out flares from fuel gas combustion devices, something that varies between J and JA, and have specific requirements for both versus lumping them into one up above in J. And then also had the sulfur recovery plants, and it was commenced construction or modification after May 14th, 2007, and has a different date for flares. And then the refinery sources that are required to monitor gases per J and JA are NOx, SO2, O2, CO2, and CO. And then on your sulfur, you've got SO2, total reduced sulfur, O2, and then you've got the list for flares and fuel gas combustion devices as well. So your niche apps. CEMS requirements are limited mainly to vinyl chloride plants, glass plants, copper smelters, and arsenic plants, and apply to monitoring of vinyl chloride and opacity. So there's not really much that hits the petrochemical side there. So, you know, no ethylene, no specialty chemicals really other than the vinyl chloride. Your MAC standards, this is where you get pulled in a lot of times for your sources. They're applicable to hazardous air pollutants that were established as part of the Clean Air Act, so benzene, toluene, HCl, mercury, Ds and Fs, etc. Approximately 175 source categories are identified in the MAC standards. So MAC UU is applicable to refinery for catalytic cracking units, reforming units, and sulfur recovery. And then you've got things that go with other stuff, HCl and TOC for catalytic reforming units, TRS for SRUs, and other MAC sources include hazardous waste incinerators, which have opacity, CO, and hydrocarbons, pharmaceutical and cement plants. We're all familiar. That's a long list of what gets drawn in. So Part 75, it originally only applied to the electric generating units greater than 25 megawatts in the acid rain program. It plays a large role in the trading, NOx banking and trading, and it extended to the NOx budget, and then it also extended to the CAIR, which is the Clean Air interstate rule. And then so the Part 75 breakdown is similar to the Part 60, but as we talked about a little bit during the DOS, it gets into some specific data substitution areas, and it's got stricter CEM requirements in the Part 60 appendices. Refinery consent decrees, which we're starting to see some of these come out on the chemical side too. You know, you can look through the Flint Hills is one that was agreed to recently that in Port Arthur that they're coming for other chemical plants now. A lot of 114s out on flares and others. But it did require the addition of some CEMS dependent upon the consent decree, so everyone was very different, even though they all did the same thing, really. Some required, you know, CEMS and stack testing on CAT units, others didn't. It just really depended on where you sat going into negotiations. And it required that all CEMS installed meet the quality assurance program of Part 60 Appendix F. And then usually, typically, what you end up having to do, one of the conditions of a consent decree is you have to roll all the conditions of the consent decree into your permit. And so you end up with these conditions forever, right? You close the consent decree out, but it's in your permit now and it's not going to change. Okay, so installing a CEMS. So here is the list of the performance specs. I didn't go through all of them because some of them I just didn't feel were applicable, but this is the list of all the performance specs that I thought may hit somebody, you know, that was coming to this training. So the first one is Performance Spec 1, which is going to be your opacity standard. It applies to all opacity monitors installed after 1983. Must be installed downstream from all particulate control equipment where condensed water vapor is not present and free from interference with ambient light. So a lot of cat crackers have opacity monitors on them in refineries, have opacity standards for them, but you can't use an opacity monitor because it doesn't meet where condensed vapor, water vapor is not present, right? So if you've got a wet gas scrubber, you can't use a opacity monitor, so you've got to use an amp to do that. So some of the performance specs there, calibration errors, you know, has to be less than or equal to 3% opacity. The response time is less than 10 seconds. Your conditioning period has got to be less than or equal to 168 hours. Zero drift, less than 2% opacity. The calibration drift is the same, less than 2%, less than 0.5%. And so, it's expressed as the sum of the absolute value, so it can be plus or minus, right? You don't have to be two above. And during the conditioning and operational test periods, the CEMS must not require any corrective maintenance, repair, replacement, or adjustment other than that clearly specified as routine and required in the operation and maintenance manual. So if you have to do something above and beyond that, you might be failing your calibration. You'd have to go back and make some changes or call it downtime. So Performance Spec 2 really applies to SO2 and NOx, but it ends up pulling in everything after this Performance Spec. Pretty much points back to Performance Spec 2, except for your O2, CO2 requirements, which have a little different calibration error range, but we'll talk about that. So SO2 and NOx must be installed in an accessible location where the pollutant concentrations or emission rate measurements are directly representative. It can be corrected so that the representative of the total emissions. So the suggested location is at least 2 equivalent diameters downstream from any nearest control device, the point of pollutant generation, or other change in pollutant concentration. So maybe a bend in the pipe, a fan that pushes air, and another tie-in, anything like that. And at least half an equivalent diameter upstream from the effluent, exhaust, or control device. What the heck does that mean? How do you measure that? The most important thing to remember in Performance Spec 2 about those requirements is that pollutant concentrations and rate measurements are directly representative. So we'll talk about some ways to prove that later. If you don't meet those requirements, there's some things you can do to help you show that where your sample point is, you're good. So the CEMS system must include a data recorder scale with a response range, including a 0 and high level. The high level chosen by the source owner is defined by being a value between 1.25 times and 2 times the average potential emission level. A lot of times it's also just laid out in the rule. But if it's not laid out in the rule, you got to come back and default to, well, what's my requirement? Like if I've just got a 100 million BTU heater and I'm required to put a CEMS on it, you've got to pick your range based on your limits to that 1.25 to 2 times. And then you've got your calibration drift test. While the facility is operating at more than 50% of normal load, the magnitude of the CD must be determined once per day for 24-hour intervals for 7 consecutive days and must not exceed 2.5% of the span value. So that's your initial 7-day drift test.
What exactly do you have to do with drift tests?
Just to show that there's no bias in the system. So typically you're doing that after a new installation or you've revised your CEMS system, something has triggered that, right? And so really it's just a measure of making sure that your analyzer isn't giving you a bad reading.
But it's also a good idea to do a 7-day drift test prior to doing a RADA.
Yes.
Because if your analyzer can't pass your 7-day drift, you're more than likely not going to pass your RADA.
That's right.
So that's always indicative of an analyzer issue as well.
So we would always suggest that you do your 7-day drift test before your RADA. There's no regulatory requirement to do that.
No, but like
It's just
2 weeks
best
before
practice.
your
Yeah.
RADA. Don't do it 7 days before your RADA.
No, yeah.
If it fails, guess what? You start, like if you start your 7-day and let's say the second day you fail, then you gotta
go back and do your RADA too.
You gotta make adjustments and then
Yeah.
you start your 7 days again.
That's right.
You still gotta do your RADA, so you better have some cushion in there. I mean, like 30 days is usually plenty, unless you have like a major analyzer issue and you gotta get a part in. Jim can take a
Well, see, I was, when I first started doing it, I was told that you do it within the period that you do the RADA, right? Do it a few days before and do it a few days after. So I was having to pick up more days just to see, make sure it was going to pass. So then we started saying, well, we're going to do it about 2 weeks before.
Yeah.
Because like you said, there's nothing that drives you to do that.
There's no regulatory requirement. So when we can,
It's just really a best practice.
right. So that's whenever we commissioned our 58 CEMS, you just got to do it within your 180-day window, really, is the requirement, because you want to do it before your RADA.
Yeah.
And so we knocked all our 7-day drift tests out at Motiva in the first, 2 weeks of operation when things became operational. And we might have done the RADA on day 179.
Right, but that's for a new installation.
Yes.
And then after that, you.
If you trigger, and that's, we'll talk a little bit about what might trigger that in the future, because there's nothing that really points to it in the rule of what would require you to come back and do, like what would be a new or reconstructed or modified CEMS. There's nothing that gives us that. So we'll talk about some scenarios maybe that we've run into in the room that say, hey, you know, I went ahead and you do another errata, you do a drift test, like you can treat it as a new CEMS, even if it's replacing an old one, right? So your RM test is the results must be equal to or less than 20% of the mean value. And we'll do some exercises. I know this is a lot of numbers and I apologize, but it's just a lot from the rules here. But results must be equal to or less than 20% or the mean value of the RM test data in the terms of the emission standard or 10% of the applicable standard. So you get to measure it two different ways. Whichever is greater and require at a minimum 9 21-minute runs. So when we stack tested, we typically suggested to do 12 just to be safe. You can throw 3 out, you get your 9. You know, some places are comfortable doing 9, but if you end up with a bad data point, you don't get to throw it out, and it could throw, you know, you could fail your errata, and then you're doing the whole thing again. Whereas if you had done one more run, you may be good.
Yep, dollars.
So what does it talk about the location of sampling? So we kind of talked about this, but install the CEMS in an accessible location. So this is something that we point out, accessible location. I don't think that means you have to go spend $1 million to go put a new platform in to meet the requirements that we talked about, as long as you can prove that it's representative, right? So if you have a place that may not meet the distance limitations, but you come in and it's an accessible location, we already have a platform there, so we stick a port in, you know, do a hot tap, stick a port in, and now we can measure it, and we'll talk about how you can prove that it's representative. So
And you think that's true as well, like on a rectangle, like on a duct versus a stack?
you've got to prove, there's ways to prove that it's representative. If you can't prove that it's representative, then, you know, I would say that you can't put it there. But the accessible location where the pollutant concentration or emission rate measurements are directly representative, so we see that language again, directly representative, or can be corrected to be representative. So it's a repeat from the earlier pull from the regs there. And then the select representative measurement points are passed for monitoring in locations that the CEMS will pass the RA test. So there's another, you know, you've got to pass the RA test. So even if you show that it's representative, but then you can't pass your RATA, you've got other problems. So, you know, you've got to pick and choose where these go. And if the cause of the failure to meet the RA test is determined to be the measurement location and a satisfactory correction technique cannot be established, the administrator may require the CEMS to be relocated. So they can come in and say, okay, we don't believe that that's representative, move it. Now you got to go spend $1 million to put your platform in. So the suggested measurement locations and points or paths are most likely to provide data that will meet all the RA requirements listed below.
So you keep saying suggested measurement locations. I'm asking because I don't have a rule from you. Does it literally say suggested?
Suggested measurement location. So the only place that ties in to where it tells you that thou shalt is in your stack testing methods. So when you go do your RA, your RATA, they've got to test somewhere that meets the requirements or do 24 traverse points across the stack, right? So everything on this side of the rule says suggested, may. There's nothing that points to.
Stack testing requirements, and then it tells you where you're going.
That tells the stack testers where they have to test and at what traverse points, but it doesn't indicate where you have to install your CEMS. So the measurement location.
If you install a CEMS where they can't do that, then hello.
Yeah, but if you install your CEMS,
I mean,
if you install your CEMS,
you can't traverse it.
that's right.
I mean,
No, I mean, you've got to take all of that. I mean, typically on a stack, you're going to see it up at the top, and that's where your stack testers are going to test. But an H2S and fuel gas may not have a port, you know, it may be 100 feet that way that we do the RATA. But as long as the two agree, then you do your stack, you know, you do your reference method 100 foot down and meet all the requirements. And if it matches your CEMS, then you're good, or your GC or whatever you're using for H2S and fuel gas.
still put them on ducks. That's my big suggestion. That's our issue, is the duct.
No room.
There's no
Yeah.
room. I mean, we diameter there though? I mean, whose right idea was to put the CEMS there? Somebody that didn't know what all the other regulatory requirements were.
Right. No, it's very true. So it's suggested that the measurement location be at least 2 equivalent diameters downstream from the nearest control device, the point of pollutant generation, or other change in which the pollutant concentration or emission rate may occur. So we're seeing the same language just to drive it home. And at least a half equivalent diameter upstream from the effluent exhaust of the control device. So here's some more wording from Performance Spec 2 around where do you select. So select as appropriate an accessible RM measurement point at least 2 equivalent diameters downstream. So this is where when you start getting into the reference method that you've got to comply with the standard and the stack testing, which we'll talk about, because if not, you've got to do the ungodly number of traverse points, which is terrible. Otherwise, you can just do 6 across the stack when you're doing a RADA, or 3 even, depending upon what you're looking at. But that should be for your stack testers to figure out. But every once in a while, it's good to go check them and make sure that the way they're running the reference method matches the rule, because if they weren't, it's going to come back on you, right? When the pollutant concentrations changes are due solely to diluent leakage, air heater leakages, etc., and pollutants and diluents are simultaneously measured at the same location, a half a diameter may be used in lieu of the 2 equivalent diameters. Right? It gets really, wishy-washy as to where you go. But if you could meet the two and half, so 2 upstream, half downstream, it's the way to go. That's the easiest way to do it. The CEMS and RM locations need not be the same. So what if I can't meet the criteria suggested? Other traverse points may be selected, provided they can be shown to meet the satisfaction of the administrator to provide a representative sample. Document why you couldn't meet the criteria. I think that's important. So if you can say, hey, I didn't meet it because of this, then you have a greater chance of winning that argument if they're to come in. And then if you ensure that you're in a location that will pass the RADA, then your argument for documenting why you wouldn't meet the criteria is even backed more. Hey, we passed the RADA. Here's the reason we didn't meet the criteria. Now we're good to go, right? If a RADA is failed, the administrator does have the authority to request the CEMS to be removed. I mean, that's not a cheap fix. You may have to order some more sample line. You may have to move your building. I mean, there's all kinds of things that can jump in the way there. What if I have a location that meets the criteria but I don't want to use it? Ensure that you're in a location that will pass a RADA. Again, that's the first. And then document why the location wouldn't be used. It's unsafe to perform the maintenance in that area. It's inaccessible, or it's not a representative location. Maybe you have later tie-ins. So you're like, I don't want to put it there because I may have something of that pollutant coming in downstream of that. I mean, this would be a lot of times where you're looking at maybe like a flare line or something, and you're trying to figure out where to put a BTU analyzer or GC or something. Most likely on heaters and stuff, that's not a problem. Maybe an inlet-outlet control device, but a lot of times flares is where you would run into that. When in doubt, conduct a stratification test to show the sample point would be representative. And so that's what the stratification test does, is it comes in and says, hey, this point is representative. We'll talk about what that stratification test is. So it's a test for stratification. It uses a probe of appropriate length to measure the NOx or pollutant of interest, because remember this is Performance Spec 2. Concentration at 12 traverse points located according to Table 1.1 or Table 1.2 of Method 1. And so I didn't put the methods in the book, but it's going to point to, if you go to this Performance Spec 2 in Table 1.1 or 1.2, you'll see what the points are there. And alternatively, you may measure the 3 points on a line passing through the centroidal area, the 3 points at essentially a third, a half, and, well, it's not a third, 16.7, 50, and 83.3% of the measurement line. Sample for a minimum of twice the response time. So you should have already set up your response time at that point. And this would really be, a lot of times you're asking your stack testers to do this, prove that it's the right place. Calculate the individual point and mean NOx concentrations, and then if the concentration at each traverse point differs from the mean concentration for all traverse points by plus or minus 5% of the mean concentration, or half a ppm, whichever is less, the gas stream is considered unstratified, and you may collect samples from a single point that most closely matches the mean. So what does all that mean? Well, it means that if you can prove that it's not stratified,
Place and you don't have to-
you're representative. That's right. Simple. That's right.
Don't make it hard.
So the calibration drift test, it can be completed during the RADA. You can do this during the RADA. It's for CO and O2 analyzers, the calibration error test and interference test must be completed during the calibration drift test. So we'll talk about what those are. It consists of conducting a zero and calibration check for 7 consecutive days while the unit's 50% of greater or normal load. And something that to remember there is 50% or greater of normal load. So if you're working on an existing source, it's not 50% of max. So if you only run it at 50%, 50% of 50 would be 25, right? So if you were at 25%, you would be good on a normal load. And then you've got to conduct that at 2 levels, 0 to 20% of the high level value and 50 to 100% of the high level value. And so that's just giving you your low and high range, your span. You must meet the drift calibration error criteria for 7 consecutive operating days, plus or minus 2.5% of the span for NOx, CO, and SO2, and then it's 0.5% for CO2 and O2, and that the average of the 7 days is not calculated and does not count. You must meet it every day for 7 days. Yep, because a lot of times if you averaged it, you would meet it.
Yeah.
So the Part 60 and Part 75 calibration error test, it's essentially the same as the Part 60, except that protocol gases are required and cylinder gases are determined as a percent of span, not range. So the wording's a little different. You could probably tell us more about protocol gases than I could tell you, but it's just a different, tell us what a protocol gas is versus what you might just use as a regular calibration gas.
There's some specific requirements by NIST. You have to have NIST traceability, and then there's a couple analyses depending on the components
Right.
of the gas.
Just a little more,
So
yeah. Thank you. So here's your equations, the calibration drift test. Here it is in Part 60. So the drift is equal to the true value of the reference minus the system response divided by the full scale. So we'll look at what those numbers could be like. But this is what the R is, the true value of the reference. So that's going to be, let's say we're shooting a 500 ppm gas, and then the system response is 480, and then the full scale is 500. Then you would do your math there to get what the calibration drift is. And then in Part 70, it's similar, except again, this is the span of the analyzer versus the full scale, the range of the analyzer is a little different. So Part 75 linearity checks. We talked some about how the DOS system can help you with this. It's a check system at certification and once each quarter thereafter for linearity. And you use 3 protocol gases, a low, middle, and a high, and it gives you specific spans what that low, middle, and high is. And then your linearity check equation, it looks similar, but it's based on the reference value, and then you have the low, middle, or high calibration gases, and it is an average of the monitoring system responses. There, the A is the average of the monitoring system responses. So the RADA, it's a validation of the source's CEMS by an outside reference method CEMS. So we're probably all familiar, you get your stack testers come in, they bring their NOx and CO analyzers, and they run the stuff up to the stack and then check versus yours. They're conducted initially, and they certify your CEMS, and you're required once per year, at least once every 4 quarters to qualify the data continuously gathered as valid. So what happens if I run for 3 quarters and then the quarter I was going to do the RADA, I don't run the unit, and then I come back up the next quarter? What would you do? Right, so you've got to look at least once every 4 quarters, and then you can stick in there operationally. So you could do it in the 5th quarter if you didn't operate in that 4th quarter, right? And you're actually still good because that would be the 4th quarter of operation. But you got to be careful when you do that because you might have it on the schedule for the 4th quarter, and then if you forget to move it to the 1st quarter, you end up with a deviation because you didn't do a RADA. But also, you're not going to go start up a unit a lot of times to run a RADA. And so you just got to track it closely, right? So, you know, it just depends. Like I know when I was at Motiva, we had a source or a small little lube unit that we would run based on economics, but we had a CEMS on the heater, and it was down for an entire quarter, and we didn't do the RATA because we forgot that we didn't roll it forward to the next quarter, and it came back up and operated, and it had operated in the prior 3 quarters. So we had to come in, you know, report that as a deviation, but we didn't call it out of control because the RATA passed, so therefore it says use engineering judgment. We'll talk about some of that later. So RATAs are conducted, I already said that, I'm sorry. A test plan should be prepared and should include the following: a project description, the organization and responsibilities of the facility, the plan and schedule itself, a description of the test procedures you're going to use, QA objectives, the description of data reduction methods, documentation and reporting procedures, and safety and policy procedures. Get your stack testers to write these. It's the easiest thing to do. They do them all the time. Then just check it versus what the requirements of the rule are. They, you know, most every company I've ever worked with on the stack testing side has a boilerplate of these and can knock it out pretty quick, and they're all pretty good. So it's 9 sets of paired monitoring system and reference method test data are required. More than 9 sets can be run, as we talked about, but a maximum of 3 sets may be rejected as long as 9 sets are used to determine. So you can't run 11 and only 8 qualified and throw 3 out still, right? You got to get your full 9 basis how many you run. So here's a breakdown of the Part 60 versus Part 75 RATA requirements. So you get over here, see, it's just pretty simple. 20% of the relative accuracy or 10% of the applicable standard. When you get to Part 75, you get, which is less, 10%, 250, or plus or minus 15 of the standard. So when you start getting into Part 75 requirements, there's a lot more to look at because, again, you got to pick the less of the 3. Whereas over here, as long as you meet one of those 2, you pass the RATA. So you could actually not pass it one way and pass it another and be good. And so the SO2 and NOx have the same requirement. CO is a little tighter, 10 and 5 versus 20 and 10. You get less than 1% for the O2 CO2, and then a CERM, what we talked about a little bit, 20 or 10% of the applicable standard. And then here, again, here's the list of the Part 75, and I won't go through it in detail, but that's the requirements pulled from Part 75. So the equations. So these are pulled straight from the federal regs. So the mean, it's just what we all know what the mean is. It's just an average of your runs. Your standard deviation, you know, I just suggest put those in Excel and put standard deviation and mean, and you're good to go. And then, but this is what the confidence coefficient is based on in the method. It's just your statistical, you know, hey, where do you land and what percentile? And then basis your number of runs. It's your runs minus 1 for N, right? So if you did 9 runs, you pick 8 at 2.365.
Or put it in your dash.
So the RATA calculation. So your relative accuracy is equal to your absolute mean, which we saw on the last page, plus your confidence coefficient, divided by your reference, your RM, which is also the equation back here. So those 3, these all come together to make your, to give you your RATA calculation. And so that's the average of the RM value. That's the reference method value. That's your stack tester's results. So here's an example of a facility that did 9 RATA runs, the reference method, so your stack testers, here's the facility, and then here's the difference. So I've just applied the equations that we talked about, broke it down so you can see each individual piece. And then, so we look at the fact here that the applicable standard is 250 ppm. You can see pretty easily we're 1.45%, so this passes the RATA with flying colors, right? You're pretty close. Sometimes you don't always see them that close. I just threw numbers up here to give you an idea. So the test audit, here's another example. Much lower numbers, so what does that do? It really drives down the error you can have, right, in the system. your reading versus the stack tester's reading. So I pulled these actually just from a stack testing report I found on the internet at a facility, and you could see that the numbers were fairly close. I mean, but you just don't have much room with a 9 ppm applicable standard. So this might have been something like a NOx outlet on an SCR heater or something like that, because you might only have a 5 ppm annual average that you're allowed. So you can see the regular method was 9.92%, the applicable standard was 5.33. You actually still pass both, but you're really tight on your regular method, but you've got room on your standard, by the applicable standard, right? So what did Part 75 do to your RADA? Gave you more to do. It says system could be biased. What's bias? It's systematic error resulting in measurements that will be either consistently low or high relative to the reference method. The precision, which difference is the degree of mutual agreement between the individual measurements using analytical method or measurement process. So we'll talk a little bit about the bias. So the bias is the mean minus the confidence coefficient. If the relative accuracy test audit data, let me start over. If the RADA data set being tested, the mean difference is less than or equal to the absolute value of the confidence coefficient, the monitor or monitoring system has passed the bias test. If the mean difference is greater than the absolute value, the monitor or monitoring equipment has failed the bias test. And you must make a bias adjustment to all of your data. So do y'all have Part 75 CEMS? Have you ever had to apply the bias adjustment factor? You don't seem very confident in that.
But
you know,
but you can only bias up. You can't bias.
right.
You can fail the bias test, but you don't get to adjust it down. You only get to adjust it.
So the bias adjustment. Here's your equation. It's kind of small, I know, but it's in the page. But it's where the data measurement provided by the monitor time, the data value adjusted for bias at the time, and then the bias adjustment factor as defined by this equation here. So essentially what it's telling you is that your system is bias low, and moving forward from the time you run that RADA, you have to go adjust all of your data to this factor. So let's say it's, just an easy number. Let's say it's 10% low. So the reference method's rating 10% higher consistently, but you're still passing your RADA. You have to go apply a 1.1 factor to every set of data till you run another RADA that shows you're either not biased, or you pass your bias test, or the bias changes and you go apply the new factor to it. So you can do that in your DAS, you can do it in DECS, you can do it in a spreadsheet outside, but some way you've got to correct the data for that bias. So here's an example. The same example we looked at earlier, but hey, they're a Part 75 facility now, whereas before they were only Part 60. And so, we got the same numbers. It's, hey, only 0.32 difference. You still pass your RADA, and my bias based on the equation given is 0.16, so it's positive. So therefore I pass the bias test. This data is good. We move on. You don't do anything. All right, so I changed the numbers a little bit. Very slightly. And look what happened. My bias is negative. You have a 3% bias low based on the BAF, or the equation for the bias adjustment factor. And so now moving forward, all the data I collect from this source, I've got to apply a 1.03 factor to until you run it again and prove that it's not biased or your bias changes. So after subtracting out the imprecision of the test, if the CEMS system reads lower than the reference test method, the system is bias low, and a bias adjustment factor must be applied to all data until the next RADA. So that's just a pull from Part 75 there about what you got to do.
So then does that mean you've got a set of 60 data and a set of 75 data now?
No, so typically you're going to be applicable to one or the other. One source is not typically going to be applicable to both. You're either going to be a Part 60 source or you're going to be a Part 75 source. Some of the things that drive you to Part 75, if you get far enough into DB, it can push you over to Part 75. Some of the new MACs and NSPSs that are coming out, if you get far enough down the line, similar to DB, you end up in Part 75. All your acid rain program, So you may have a generator, a turbine at a refinery that generates electricity and steam for the refinery, but if you sell to the grid, if you didn't sell to the grid, you'd be Part 60, but when you start selling to the grid, if you sell enough, 25 megawatts, you end up in Part 75.
So let me correct you just a little bit. If you are, you may very well be applicable to both Part 75 and Part 60 on the same unit at the same time. Just because you fall under Part 75 doesn't get you out of doing Part 60. And
Yes.
most Part 75 systems do have multiple calculations for the same parameter, some of which are biased, some are not. Some follow the different validation rules for Part 75 versus Part 60. So it can kind of get confusing because you get different numbers for the same thing.
Yeah.
They all really.
Thank you. You're correct. So what could cause us to fail a RADA? Has anybody in here ever failed a RADA?
Well, not when I was here last year. Actually, my ride got postponed. I have next week.
You got one next week?
Yeah, next week.
Well, we'll talk about ways that you can hopefully pass it, right? So the reason you might fail a RADA, failure to correlate properly. So your CEMS system and the reference method, the pressure, temperature, percent water in the system, they're different. So they're not representative or something like that. Or, the stack testers are using the wrong pressure and temperature indicator where you're using a different one. They're using one downstream, you're using one upstream. There's things that can affect that. Incorrect calculation or round-off procedures, so we kind of talked about that. So if you're not precise in how you're rounding, you can get in a problem. Incorrect accounting for source-tested system analyzer bias, cheating. I hope nobody's cheating, but the flue gas location may be stratifying, and you'd be surprised. I've run RADAs on sources where you pass it for 2 years in a row, and we go back in year 3 and you no longer pass it. And it's like, well, we made 5 tie-ins downstream of it. Your stream may be stratified now, so sometimes you have to go run a stratification test again to, or look at moving your reference method, because a lot of times at that point you're probably not going to move your CEMS, so you might have to pick a new stack testing point. Interferences by other flue gases, incorrect calibration gases, that could be something that could cause a problem. Improper calibration methods or a failure to calibrate would most likely lead to that. Your uncorrected ambient or source effects, so again it ties over here to failure to correlate properly. You could have a DAS problem potentially. Somebody forgot to put that bias adjustment factor in and you hadn't been applying it, and you're counting on your DOS data, and oops, now we're not passing the RADA, but you would if you applied the DOS factor. Or the BAF factor, too many acronyms. System design or operation problems, that could be another reason.
Just something, you mentioned how you have to do at least 9 runs, 12.
Mm-hmm.
I don't know if it's the same in most groups, but I know for us, especially when I was learning it, what we're told was you have about 3 runs to get, like after the 3rd run, you're the RADA testing. So you can kind of, if you look at the first 2 runs and you know like how close your numbers are to your RADA numbers are, you kind of say, okay, let me call it up, try to figure out what's wrong and schedule my RADA like a week later or whatever. But for our regs and our permit, like after we get past the 3rd one, you're committed, you must finish.
Okay, so that's it could be state requirements, it could be permit driven, because there's really nothing that points to it in any of these methods that say once you get, I could get to run 8 if there's no, state of Texas isn't going to like that. I know that because I've worked with them enough that's where they're considering the 3 runs as you're committed. But also the confusion there might come like during a performance test, during a stack test, so where you're doing something other than your RADA. You do 3 runs, you are an official stack test if you calibrate it and follow the method and all of that. So even if you're doing a 4th or 5th run, you can't do an engineering study and do 3 official runs. Does that make sense? So you could do 2 runs and stop. So I think that maybe what you're talking about, it could be for RADAs too, and if your permit says that, then that's what it is. But typically that's more tied to your performance test. If you do that 3rd one following the method precisely, you have to turn those results in, even if you intended for that just to be an engineering study.
What if it was 3 less than 1 hour?
If you don't follow the method,
Yeah.
you don't have to turn it in. It's an engineering study.
That's just like just doing that for your own personal knowledge versus.
Yep. So,
following
the method could say run an hour, and if I run 45 minutes and do 3 runs and you didn't follow the method, or I don't calibrate at the end, You know, I calibrated at the beginning, but I didn't calibrate at the end, so I didn't do an official run because I didn't follow the method. You could run, I'd want to do a 5-hour run just to see what it is in that time. You didn't follow the method because it's laid out. So that's you can do that. So the CEMS systems must be installed and certified. So a continuous monitoring system are approved only after they have been installed, a 7-day drift test has been performed, and you've passed the RATA. And typically that has to be done within 180 days. A lot of times that's driven by your permit, but some MACs you have to watch, like MAC Triple U for refineries for sulfur recovery plants gives you 150 days. So, you know, just so you got to check the rules sometimes, because a lot of times your permit may even say 180, but there may be a driver outside of that that's a little shorter. It won't go longer than 180 days, typically. So more certifying methods are found in Part 75 Appendix A. You've got some ISO standards and European Union standards. These are just other methods you can run to qualify a CEMS that you get outside of Part 60. And then modifications require certification. So what constitutes a modification? I think
Right?
nope. I think now is a good time to take a break. Let's take 5 real quick, and then we'll come back at about 10 after and get going on what might be a modification.
helps somewhat, but I mean, it sucks a little bit. It's tighter.
All right, y'all ready to get back after it? So, what constitutes...
I'm sorry.
Oh, you're good. What constitutes a modification? So we'll talk about some of these. So, in writing, there's no specific instruction to revalidate a CEMS based on a modification. Only thing I could find, I searched ADIs, I searched everything I could come up with. Otherwise, the owner or operator of an affected facility shall conduct a performance evaluation of the COMS or CEMS during any performance test required under 60.8 or within 30 days thereafter in accordance with the applicable performance specification in Appendix B of this part. The owner or operator of an affected facility shall conduct a COMS or CEMS performance evaluation at such other times as may be required by the administrator under Section 114 of the Act. That's the only thing that I found that points to when might you have to do a recertification.
Part 75.
So,
Every time we've hired an outside consultant to do CEMS training, and I challenge them all the time on recertification. That's low line for my opinion. I mean, who doesn't know that? But every time, you just need to reference back to Part 75, because Part 75 does have recertification language. But you can, I do have a table that I built for recertification. Like if you do this, this requires a RADA,
Yep.
Because I got tired of getting asked all the stupid questions, so I just got a little table.
Sorry.
It's Camden, it's Camden.
She said it out loud.
so we'll just consider some of these. Let's look at when might a recertification be necessary. So if you put a new sampling conditioning system on your analyzers, would you run a RADA? What's your risk tolerance?
We know it's part of the system,
Yep.
so we do it. I put it in the truck.
So this gets totally into company decisions mostly. So that's why I wanted to talk about it, because you say yes, you say no, but a lot of times it just breaks down to guidance, corporate guidance. What's your interpretation? Yeah. So I can see yes, but I can also have argued no.
Yeah. Well,
I don't help by saying that, but when I sat on the other side of the fence in Motiva, we argued no for this, and we had a reason why.
did you win?
We didn't have to. I mean,
So
you just document it and
within the company.
yeah,
And
we just documented it, and you know, it passed the RADA the next time we came around, and we were good to go.
well, that's kind of.
But we didn't go do it then, like say it was due
Yeah.
3/4 from
But
now.
that's credible evidence,
Mm-hmm.
you know, like you can say, well, we replaced this, we didn't test, but then when we did do our RADA, you know, when you're trying to justify what you've done to the state, you could use that as credible evidence in your defense.
Yep. So what about a new CEMS analyzer to replace an old one that was defective? I just needed an upgrade. That one's easy, right? So what about installing a new board to replace a bad board? I got struck by lightning. My CEMS analyzer on my cat cracker burned up.
Yeah.
Nope. You know why?
No,
Because it's not measuring anything. It was just the electronics.
What if it was a detector cell?
If it was a detector cell, that's different, but we didn't have to replace the detector cell. It was just the computer portion of the analyzer. When we put a new board in, it read, we didn't touch the IR.
good job. We haven't had to do that yet, but that was a good
So that was
job.
when we actually lived. We had a lightning strike at the cat cracker. We burned up our board. Had to go get a stack test company to bring in a temporary one because it was an ancient analyzer. But we found a board. Somebody out there had a board.
Not all the HSEU, all of them.
But then we put it on the list to be upgraded, and since I've been at Sage, it's now been upgraded to a new analyzer.
That's a good job, though, because you didn't know if it's not
right.
affecting your delivery.
That was our reason. So, I mean, you may have a different reason as to why you would, but, our argument was we didn't touch the detector, so therefore it was still good.
I like that.
So audit samples, this was a question from when we had done this prior. There are no audit samples required for CEMS, so I put this slide in here. Refer to US EPA Emission Measurement Center for available audit samples and what methods. So typically your audit samples are going to be on your performance tests. I think especially around species like HCl and others where you can get some contamination, they want to see some audit samples. So if you ever have any questions, that's where to go, is the measurement center. Go look up the methods. All right, so Appendix F summary. So this is where we get into your QA/QC. So here's some terminology. It typically tends to align with Appendix B, but you bring in some new terminology. So there's where you're talking about the diluent gas. The span value is the upper limit of a gas concentration for measurement. 0, low level, and high level is the gases chosen to challenge the CEMS. Your CD is the difference of the CEMS output versus specific challenges. Your RA, a little bit different, but the absolute mean difference between the gas concentration or emission rate as determined by the CEMS and the value determined by the reference method. And then this is where you get into your out of control. It defines it as the beginning of the period after completion of the 5th consecutive daily CD check greater than 2 times, or the period immediately following the completion of a CD daily check that is greater than 4 times. So during an out of control period, the CEMS data may not be used to report nor be counted towards meeting minimum data availability. So if you've got 95% uptime, you don't get to count it. We'll go through some examples because that 2 times always happens on Saturday, doesn't it? Runs for 4 days, Tuesday, Wednesday, Thursday, Friday, and then Saturday's your 5th day, and guess what? It doesn't get fixed till Monday. But the good news there is you only start counting at the 5th day. You don't go back to day 1, and if you're 4 times, you have to go back to the last calibration. So you may lose 24 hours there if you fail it at 5 o'clock in the morning and the last good one was at 5 o'clock yesterday morning. You have 24 hours of out of control there.
Actually, in that particular appendix, I think it says also if you drip 2x, if you fail 2x, you're supposed to correct it.
You're supposed to make an adjustment, make an effort at an adjustment. So later that day, we had an analyzer tech go look in the building, and he looked at the analyzer. Did he try to make an adjustment? I don't know. We typically would just go back to the logbook and try to document that. I haven't seen places take a deviation for not attempting to make that adjustment on day 1, but I know that it happens a lot that, oops, I was gone Thursday, Friday, Saturday, Sunday, and I came in Monday, and you don't meet, you hadn't gotten to out of control time yet, but you didn't make an attempt on Thursday because that was my unit and I was on vacation and I didn't ask anybody to cover it. So it's a good point and something to look for, because if you had a picky enough auditor come in, they could look at that and say, "Can you go show me the logbook when you were 2 times out on day 1, and let's see what you did to try to correct it." And if you didn't do anything, potentially you have a deviation there. I've never been asked it. I'm not sure that most of the regulators in Texas know that to that detail. But I don't have a lot of experience outside of Texas and Utah with CEMS from my experience at URS. So calibration drift requirements, the difference between the CEMS output and a reading from a reference value. It must be performed at 2 concentrations once every 24 hours, and typically the gases are a 0 gas and a span gas. So your nitrogen, or you may be shooting something like anything that's going to get your analyzer down to 0, and then a span gas, which is going to be defined by what your analyzer range or what your standard is, or what your federal applicability says you must span to, something like that. If either the low or span CDs, which we just talked about, is 2 times out for greater than 5 days, must be made immediately. A correction must be made immediately following the 5th day to avoid an out of control period. Now, again, we just talked about the 1 day you got to go make an attempt, but we're trying to avoid out of control time versus just maybe taking a deviation there and having to throw some data out. So immediately following the 5th day, you would begin to take out of control period, and we'll go through some examples on the following slides. If either the low or span CD is 4 times out, corrections must be made immediately, and all data for the previous 24 hours is considered to be out of control. So most places I've ever been just have an automated system at, really typically early in the morning. I've always interpreted this every 24 hours though to be a daily 24 hours. So if I ran it at, midnight, then the next day came in and ran it at the end of the day at 5 o'clock in the afternoon, you'd still get to count that as you passed your CD for a daily check, right? It's once every day. I don't know if that's,
Part 75 is a little bit more restricted, they give you 26 hours.
yeah. So they don't want you going
They don't want you playing.
12:59.
Quite like.
Okay.
I have a question on the zero gas. If you use nitrogen, because I didn't realize this, I just recently heard there's a CEMS grade nitrogen and versus an industrial nitrogen, and I guess we've always used just industrial grade, but do you know anything about
Well,
the difference between the?
That's where you're going to get into like maybe using a protocol gas. So if you're being driven to use a protocol gas, then I can certainly see where you would need to use like the NIST traceable zero gas. Our gas expert stepped out back there. But maybe we'll save that for when he comes back in. Because typically you have to go show, typically you have to show your certificate of analysis regardless of whether it's a protocol gas or just a measurement gas. So if you're using industrial grade nitrogen, does it come with a certificate of analysis? See, because you are supposed to be using you should be able to produce a certificate of analysis for all the gases you're using, whether you're part 60 or part 75, just the protocol gas is stricter.
Yeah, they don't call it a primary standard, it has a different name. It's like a CEMS grade, but it's not, I don't think it's called.
I had never heard of a CEMS grade gas, but when he
Praxair
comes
told me
back
that
in, let's ask him because
Yeah, like.
I mean I'm gonna guess that he's gonna know that. I always just looked. We always took the COAs, right, and
Yeah.
logged them and said this is what we're using and checked the expiration dates and all of that. But I don't know the difference between maybe the two grades of nitrogen. I don't know if one maybe would be better for your analyzer. Doesn't have as much, particulate or something in it.
Yeah.
All right, so here's the part 60 and part 75 calibration drift test specifications. So again, you see part 60 is a little more lax. Part 75 gets into some more requirements. So less than 2.5% of span for SO2, same for NOx. You get 0.5% for O2, CO2, and then if you've got a flow meter you're using, you get less than 3% of 1.2 times the potential flow. So you're not looking at actual flow, you would go to potential in that case. Part 75 is 2.5% of the span, unless the span is less than 200, then you only get 3 ppm. And then your O2, CO2 is the same, and your flow is less than 3% of span. So there you would go to span. Here, if you have a flow, you would go to potential flow. So here's a calibration drift test example. So every day I'm running, I'm looking good, and I get to Friday, hey, we work 980s. So guess what? It's my Friday off, and I'm out in the boat, and I'm catching fish. I don't really care what's going on at the plant. And I get a 6%, and then Saturday I get a 9.6%. This is an SO2 CEMS with a less than a 2.5% of span requirement. So any action required based on that. So there's a 2x. And there's a really close to 4x, but look at that. It fixed itself on Sunday. The best I can tell you is that per the rule, somebody should look at it on Friday.
On the 6th, you
Yep.
should have at least looked at
You
it.
should at least look at it, but there's nothing here. Yeah, and there's nothing here that says I've got to go do anything. Maybe you had a good buddy who wasn't working 980s who came and fixed it on Saturday. I don't know. All right, so now we're still looking at an SO2 CEMS. Does that look pretty? How much downtime would I have there? Out of control time.
Wow.
Yeah, somebody wasn't doing their job, huh? Hopefully you don't ever see that.
Somebody forgot that analyzer existed.
So you'd come back in here, because you came back into 2 times. That actually,
Yeah.
you're good to come back and quit counting downtime, but you'd have to go all the way back to Sunday at whatever time the calibration was done. Yeah, if you passed it on Sunday, but
Yeah, if yours is trended as ours by Wednesday, yeah, you gotta call the CCQ director. You gotta notify the CCQ office.
All right, so we're looking at a CO CEMS. And now I've got 5% of span, less than 5%. So is there any action required in this example? It's Christmas holidays. Come on, there's nothing to happen. That's right. So Saturday, ooh, I'm a 4 times.
You're at forest on Saturday, you get progressive.
Mm-hmm. Yeah, it started on Christmas Day. I don't have to go to work on Christmas Day. so I'm a 4 times here. Do I have to go all the way back to Wednesday?
Yeah.
No, because these are within
Oh, that's it. That's
these
right.
are within 2
That's
times.
within the 2 times, yeah, you're right.
So these are within. They're outside of the 2 times, but they're not outside of the 4 times. So in this case, you would go back to Friday and have 24 hours, right? Or you would actually have 48 hours because I didn't pass it again until Sunday. So if I had come in here and run this, 30 seconds after my bad one or 2 hours after my bad one, I would have 26 hours, right? Because I would go back. But in this case, I didn't come in and run it until Sunday morning, and I got back to 3.2%. So I've got 48 hours of downtime, out of control time. Does that make sense? All right, so another CEMS example, or a CO example, I'm sorry. Again, 5% of span. Is there any action required in this? So how much? That's right, so you're over 5 days.
Yeah, you went 5 days a week.
I'm right on the edge. I really should have gone and looked at that analyzer, but man, I had 37 other ones to go look at, and I just didn't get to it.
Yeah.
How much downtime do I have? Out of control. I'm sorry. I can. To me, it's the same thing. But how much out of control time? It doesn't count towards your uptime, so it's downtime too.
Well, you're saying you start counting it after the 5th day.
You start counting it
But
after
you
the
don't
5th
go
day.
back 5 days.
You
So
don't go back
would
5
have to
days.
do, what, 48?
Right. You'd have about 48 because I didn't do anything on Sunday and Monday when I came in after my weekend. I fixed it, so now I'm back below even the 2%, and so I go Sunday, Saturday because of going out on Saturday,
Now,
right?
If you recalibrate it the day you find it, you still have downtime? Or
If-
you correct it?
Yes,
They
so
have
if
good calibration.
yes, so again, because most of them are usually set to run at a certain time, so you're going to have 24 hours, 24 hours, 24 hours, 24 hours. If I come in and run it, directly after, you might have just a few minutes of downtime, but what I typically see, if I've ever seen it go out on 5 times, is I've at least got 2 more hours because our auto cals ran at 5 o'clock in the morning, and the analyzer tech comes in Monday morning, and he says,
I see
"Oh,
what
my
you're
analyzer,
saying.
it's gone."
So
And so you may still have 2 hours of out of control time before he goes and checks the
So it's
analyzer.
difference between when you got that cal and when you corrected
Yep, so it's
it.
immediately when you go out to correcting it, whether that be 2 hours, whether it be 24 hours. So when you hit that 5th day of a bad cow, or greater than 2 times, you immediately start counting out of control until you get a good cow.
I'm thinking that, you got me thinking, I don't know if we start our out of control time. I really think when we go to a 2X, we start it.
Way back to the 5th, this is the 5 days. The rule is, to me, is fairly clear that you started immediately starting after the 5th day. And I've talked to stack testers about this. That's the way we've always reported it. And I say we, that's the way when I was in industry we reported it and didn't have pushback on that. That never showed up on an NOD or NOE.
But on 4X, you go back.
4 times you go back to the last good cow, and 2 times you just go back to that 5th day. Have you had any different experience with that?
No, the difference with Part 75 is you only go forward. You don't get this going backwards business. But you also, if you're out of spec, you're out of control from that going forward. You don't get the 2X, 4X business.
So CGAs, required once per quarter on the CEMS to qualify the data gathered as valid. They're not required in the quarter that you run the RADA. should be conducted in no more than 3 consecutive quarters, since the RADA test will be required 1 quarter per year. Now, I will tell you this. The CGA is only required if the rule calls for it. So if you've got a heater that's not applicable to a MACT or an NSPS that requires a RADA, you can run 4 CGAs. But here's where they caught it. The EPA kind of found that recently, and what they did is with the heater and boiler MACT, they make you go do a RADA. So up until heater and boiler MACT, if you just had a heater that had a CEMS and there was no federal driver, the state just said you're greater than 100 million BTU in Texas, and you got to put a CEMS on. You didn't have to do a RADA, and even in the permits it would say, you know, you could do 4 consecutive CGAs, so just a little cost savings. But by getting applicable to the heater and boiler MACT, now they've drugged pretty much all the sources in that if you've got a CEMS, it requires you to run a RADA. So the CGA is a challenge gas at specific ranges to test the CEMS analyzer. The first audit point is 20 to 30% of the span, and the second is 50 to 60. And note, you can't use the same bottle, so you've got to use 2 separate bottles to make that happen. I don't know how you would run it, but I guess there's some gases that that would have a mixture potentially, that you could have a range there that's enough. But it's just a note in the rule that you've got to use 2 separate bottles. It must be conducted at least 60 days after the previous CGA or RADA. So, you know, you got to kind of schedule those so that you leave yourself enough time that you don't get up against the quarter, but they've got to be at least 60 days apart from either the RADA or the CGA before you go do another RADA or CGA to qualify the system. You challenge the CEMS 3 times at each audit point and use an average of the 3, and the results must be within 15% or 5 ppm, whichever is greater. You run the gas through the normal CEMS conditioning system. At a minimum, the gas must be introduced between the probe and sample line, so it's got to go back up through the whole system. You can't just shoot it to the analyzer, right? You're showing that you're qualifying your system. And then the CGA calculation is the accuracy of the CEMS equals the average CEMS response in the unit of the applicable standard minus the average audit value of the runs times 100 to get your percentage. So here's an example. If the span value on my cat cracker CO CEMS is 1,000 ppm as required by NSPSJ, what range should your CGA bottles be within? Well, once you run your CGA, well, first off, what should my range be in? It's easy, it's 1,000 ppm. Yep, so 500 to 600 for the span.
200 to 300.
Yeah, and 200 to 300 for my 20 to 30, for my low value, and then my high value. So 200 to 300, 500 to 600. Anything in that range, you can use those 2 bottles. So once you run your CGA on your FCCU, you get the following results. My bottle at 20 to 30% of span was 231 ppm per the certificate, and my analyzer averages 235 ppm over the 3 runs. So do you pass the CGA? Well, hold on, we can't look yet because we got to look at the 50 to 60%. So my bottle is 572, and my analyzer averages 560. So I'm at 1.7% of the low and 2% of the high. So I'm well within range. You pass your CGA. So what are our CEMS out of control periods? Well, anytime you fail a RADA, out of control. Failure of a CGA constitutes an out of control period. If I fail the 2-time daily calibration for 5 consecutive days, the downtime begins at the completion of the failed calibration on the 5th consecutive day. And the downtime ends when a calibration is passed. That's for that specific example. Or a failure of the 4-time daily calibration, and it goes back to the last good. So downtime ends when a calibration is passed. For these 2, you gotta go run another RADA to qualify your system. If you fail a CGA, you gotta run a RADA. If you fail a RADA, you gotta run another RADA. Hopefully you pass that one.
What is the percentage on a CGA? To be less than?
Yep, 15% or 5 ppm, whichever is greater.
On that last example, you consider that 12 ppm right there on the 60%?
What's that?
It says whichever is greater, so 12 ppm is your difference between those 2, right?
Between 560 and 572, the difference is 12 ppm.
Yes, yes.
So that's, did you pass that based off of 4 or 5 ppm?
Yes, because it's whichever is greater. So you get 15% or 5 ppm, whichever is greater. So 15% in this case, the 12 ppm is 2% within the range. Does that make sense?
Right, I thought it was 2 separate deals, but yeah.
No, yeah, yeah, that's a good question. Or, so we've got an or, results must be within 15% or 5 ppm, whichever is greater. So where you run into this 5 ppm a lot is if you ever put a, like a low NOx control or something, like SCR is a good example. I see a lot of 5 ppm annual average on an outlet to a NOx on outlet of an SCR. So your applicable standard is 5 ppm. You can't use 15%. Well, you wouldn't want to because it's such a small number, but it lets you bounce up to 5 ppm because it's greater, right? So if your 15% is 100 ppm, you get to use 100 ppm versus 5.
Okay.
Good question. Thank you. So there are specific data substitution requirements in Part 75. Guess what? Part 60 is silent to it. Doesn't tell you what to do if I get bad data. It just says use engineering calculations.
Yeah, and you better have something because we did it wrong.
So,
I mean, nobody ever really thought about that part of the requirement.
so the last time I did this, we had sites from California, Louisiana, Texas, Illinois, and Montana. So we talked about some. So, outside of Texas, is there, do any states point to specific guidance? Do you guys that aren't from Texas know, is there anything that, in my experience has been that there's not a lot of Part 60 data substitution specifications.
You see it in some permits. Pennsylvania's got some specific things.
Yep. But some of them too are starting to point back in permit requirements to Part 75, even though you may not be applicable, it'll say something along the lines of, follow the data substitution, because at least it's laid out there, and we'll talk about what some of those are.
A quick question.
Mm-hmm.
For out of control periods for a MAC triple U CEMS,
Mm-hmm.
aren't those requirements stricter than the NSPS?
So that's a good question. I'd have to go look.
I thought it cuts it in half, right?
On your sulfur recovery units where you're required. So, yes, and then sometimes even consent decree are more strict than that. So, I tried to work in as much as I could about, Part 60 and Part 75 without going too much into like specific examples for triple U, because there would be a lot of people that it's not necessarily applicable to. The best I can tell you is just you've got to look anywhere that requires you to do that. You've got to go look within that set of the rules and see what your requirements are. So unit's not in operation. So this was a question I had and threw in an answer here that we found after some research. If a unit is not operating or operating on just pilots, no out of control periods would be included. A unit must be in operation, i.e. have a load. Data should show that only pilots were lit for a heater, for instance. And so let's say, for example, a facility has a 0.035 pound per million BTU limit on NOx, and NOx is measured from the pilots, and you have no firing rate for the heater. It's very, very small. Therefore, your pound per million BTU is elevated well above the 0.035 pounds per million BTU because you have no divisor, but the heater is not operational. So we go all the way back to 1975 in an ADI that says that pilots constitute less than 0.5% of the heat release for a unit, and therefore it was not the intent of the regulation to cover such insignificant sources. Pilot lights are not considered to be combustion sources per 60.104 per the ADI, which would mean that if you're not in operation and you failed a 2 or if you failed a 4 times, I wouldn't count that as out of control period. But you're probably still keeping your, maybe you're in a turnaround or something and you don't have your unit turned off. You're in a small little pit stop and you're coming up 3 days later and you happen to fail a 4 times calibration, but your heater is not running. I wouldn't take out of control basis for that because it wasn't operational.
It's good to remember this. We have a lot of times where we're actually curing refractory, so that's all you can have is pilots.
Right.
Especially right now, without US, it's
Yeah.
usually just shut off our SIMs and shut off our heaters.
We did that for a while, we did that at one of our facilities, not here, it's just in
Sorry, got a gunshot.
But I mean, they forgot to turn it back on, so then we're up and running for a week and go, oh.
That's what I would be, that's what I would be afraid of, but it depends on how long it's going to be down. And then,
That's where your DOS was put in.
you got to work in.
He's not paying attention.
Yeah, she just had a sales pitch for you. So CEMS reference methods. So here's where we get in. We're going to talk a little bit about some of the stack testing methods just so you're familiar with what your guys are out there running. So what we're going to cover today is reference methods 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 15. I know that's fast, but there's a bunch in between that I'm going to skip because they're probably not applicable to CEMS. And just, if you ever have any questions, I would say get with your stack testing companies. So we've got the traverse points, how to establish your sample site, your velocity, CO2, O2, and your molecular weight. These three you typically run with almost everything you do, unless you just have a concentration limit. So if you just have strictly a ppm limit, you can compare just your analyzer numbers. But if you've got any concentration limit, any factored limit like a pounds per million BTU, you've got to run your velocities and traverses to be able to establish what that number is, and then also get this molecular weight to make the equation work. So then reference method 4 is your moisture, 5 is PM, 6 is SO2, 7 NOx, 9 is your visible emissions, opacity, 10 is your CO, and then 11 and 15 are similar, but which one you choose to run can depend on what type of stream you're looking at, because one's H2S only and the other gives you total reduced sulfur. So everybody that's JA will be running reference method 15 very soon. Yeah, on flares. Not necessarily on heaters, because it's H2S still. So a lot of pictures here from the reference method. I tried not to take much of the words just because the pictures a lot of times do justification. But this would be a typical 6 traverse point, basis meeting your requirements over here. This is how you establish the where you test, right? So here's your measurement site, and then here's a disturbance because here's a bend in the pipe, and then there's my exit to the stack. So I've got to fall within, you use the numbers here on the chart to realize how many traverse points do I have to use. So, if I'm down here in this level, so I'm at 16 until I hit 2.5 and 7. I've got to do 16. That's a pain in the butt for the stack testers. You drop down to 12, and then you can go to 8 or 9, depending upon what your disturbances are. And something when you're talking to stack testers, upstream and downstream is swapped.
Yeah, it doesn't make sense.
It doesn't. So, I think of upstream and downstream. I've got a crude unit, so upstream would be I'm feeding it from my tanks, and downstream would be everything that the crude unit feeds. From a stack testing standpoint, flop that. So this is upstream. No, this is downstream, and this is upstream. So, it can be confusing. This is downstream because here's my site, it's down. That's the way I remember it. Here's my sample point, it's down when you're thinking of a stack, and then here's my sample, it's up. It's backwards. So reference method 2, velocity and volumetric flows. So this is just what your stack tester's pitot tubes look like. You typically have a thermocouple here in the middle. It's got to meet certain calibration requirements, and they run all of that and have to provide it as part of their data in the stack testing test. And then you have to have leak-free connections, and you do a leak test on the system, and it comes down to a manometer, and that gives you what your flow is based on differential pressure, right? So reference method 3, CO2, O2, and molecular weight. So a gas sample is extracted from the stack by one of the following methods: a single point grab sampling, single point integrated sampling, or a multi-point integrated sampling. So there's a bunch of methods within method 3. One of them's like a pyrite, so it really is like you go take a hose and you run it off your stack, run it into your stack, you run it off your sample line, and you just take it and it changes the color of the material up to a certain point, gives you your oxygen concentration. Or you can go all the way to using the CEMS to measure it. So the gas sample is analyzed for percent CO2 and percent O2, and then for dry molecular weight determination, either an ORSAT or pyrite analyzer may be used for analysis. And then there's the equation for how you get the dry molecular weights based on CO2, O2, and the difference of nitrogen. So reference method 4 and 5, really you just typically see this go hand in hand. Method 4 is simply how you get your moisture content in your stack. So you've got your stack test, your probe here, here's the stack wall, runs in through a heat, this is all heated, it runs into a heated box, the filter is heated, and then it comes down and you start knocking out your moisture. So you've got, typically you have water, and just in a PM test you would have water, dry, and then silica gel. And then you would weigh these impingers for the difference from when you began the test, and that gives you your moisture content basis, is how much weight has increased here. And then it all comes down to, there's a vacuum gauge, and it goes through a pump and then into a dry gas meter, and then you get a reading on what your flow and everything is. So reference method 6, sulfur dioxide, 7 is NOx, and 10 is CO. So I put these all together because they tend to point back to reference method 6. So typically the methods are performed today with automated test methods, which are methods 6C, 7E, and 10. Below is a drawing for a method 7E approved sampling system. So this is going to look a lot like your CEMS system. It's just going to be in a stack tester's trailer. So this is a sheet for method 9. I'm sure a lot of people have opacity requirements, and you probably have a contractor, maybe a staff member that reads these, but you got to fill out something similar to this to get your visible emissions. So you get a little more intricate every time you move up a reference method. There's just different, you still have your probe and everything's heated, your sample line and a filter, but you've got your impingers and your ice water bath. This reference method 11 for H2S is midget impingers, they're little bitty, about that big. And then it goes again to a dry gas meter, and then you're getting your H2S concentration basis, what you're catching in these impingers here. So reference method 15, which looks at total reduced sulfur, is a little bit different. It's a GC to get the total reduced sulfur. But there's specific, there's a way you've got to set this up, and the stack testers know what they're doing typically if you're looking for method 15. But again, in the refineries, you'll start seeing, if you were doing a method 11 maybe to prove or test a H2S and fuel gas analyzer that's on a flare system, you're going to be moving to a reference method 15 very soon. And here's some other reference methods we won't talk about. So H2SO4, inorganic, lead, HF, fluoride emissions, total reduced sulfur. There's another reference method for 16. You don't see it run very often. It's typically reference method 15. PM, which is an in-stack method, that's a little different setup. It just has a different filter on the front of the probe versus being a glass nozzle. And then you have a filter instead of a nozzle. And then you get into, reference method 19 is your F factors. That's how you establish your FD for cases where you're looking at, establishing a flow. You get it from here. Reference method 20 is specific to gas turbines and NOx. 21 is VOC leaks. 22 is another visible emissions. 25 is your total hydrocarbons, HCl, and metals is reference method 29. So we've got about 10 minutes till a 3 o'clock break. Let me see how many slides I have left. We'll see if we want to try to finish or just... Do we want to come back after 3, or do you want to try to get through it in the next 10 minutes?
Are you going to get through it in the next 10 minutes? Is the question. I'll shut up later.
So I'm on 72 and I got to go to 86. Keep going? Okay, we'll see what we can get through. We won't stop. I'll go back to the... Okay, so types of requirements for a QA plan. So a QA plan is required and it includes the following things: an organization chart, whose responsibility is the CEMS, what are you supposed to do around them, forms used, reports, operations and maintenance manuals, review the CEMS system. So you got, the easiest thing to do here, we tell people take photos, talk with CEMS technicians, talk with environmental staff, and talk with operations, because it takes all of that to put it together a lot of times. And then list of spare parts must be kept on site, and you better keep those spare parts on site. If you list them in your QA manual, you better check that, because they will go look at it from time to time. And then they also like to see this kept up, the organization chart. They like to see if your manager changes or whatever. If you list them, you better check them. That's why sometimes it's best to just start like maybe at who manages the CEMS versus going all the way up the chain or something like that. And then remember, the QA plan is a living document. It does need to be updated regularly. Effective maintenance. It establishes PM procedures. It's a checklist maybe that can help with preventative maintenance. It's proactive parts replacement, and it's understanding your CEMS system. That's what we like to tell people. If you understand it, then you're probably doing effective maintenance on it. And then it's also keeping spare parts readily accessible, because CEMS systems do and can and do fail. Another thing that is, best practice of effective maintenance is keeping that logbook. And that logbook can either be hardbound or electronic, and it should include the date, a statement of the action being performed, possible causes if there is a problem, actions taken to prevent the problem from reoccurring, and then who performed that maintenance is another thing that we didn't have this a couple of times and got dinged on it for, well, who are we supposed to go talk to know if they actually did that? So. Data substitution. So, Part 60, during periods considered to be out of control, data may not be used in calculating emissions compliance, nor be counted towards meeting the minimum data availability. So again, no explicit instructions. NSPSJ, which is refining, does say when seeking to comply with the SO2 standard, when emission data are not obtained because of continuous monitoring system breakdowns, repairs, calibration checks, zero and span adjustments, emissions data will be obtained by using one of the following methods to provide the emission data for a minimum of 18 hours per day in at least 22 out of 30 rolling successive days. So there's a test method described here. A spare continuous monitoring system or other monitoring systems as approved by the administrator. I mean, you really have to get into, it's hard to get out that much unless you lose an analyzer really. But it's just some guidance there. It's one of the only ones that tends to point back to it in an NSPS. Part 60, many TCEQ permits state missed measurements shall be estimated using engineering judgment and methods used to record. This does not mean you get to manipulate your Part 60 data availability. Rather, you just use engineering calculations for emission calculations during an out of control period. So they're saying if you can't rely on your data, your engineers should know and just go use that data. So Part 75, during periods considered to be out of control data may not be used in calculating emission compliance nor be counted towards meeting minimum data availability. Unlike, I don't know where that came from. Anyway, unlike Part 60, Part 75 gives explicit data substitution instructions. A few variables determine what data substitution is appropriate. So what's being measured? SO2, CO2, NOx, flow rate, heat input, moisture, all these things. Data availability percentage of quality assured data in the last year, and then the duration of the outage. So how long was the event that I need to substitute data for? The concept is the less data available and the longer the outage, the higher emissions you must substitute. It's kind of painful, right? So they're saying if you don't have the data, we're going to make you use a prescribed method, and it's typically higher than you would have recorded. So here's your options. HBHA is the average of the quality assured, which is hour before, hour after, by the way. Average of the quality assured data the hour before and the hour after the outage. The percentile could be 90th or 95th. Top percentile is historic hourly emissions the past 720 or 2,160 hours, depending on which pollutant you're looking at. And the maximum, the highest hourly emissions in the past 720 or 2,160 hours, depending on pollutant. The maximum potential is a calculation that's provided in Appendix A of Part 70. So here's an example of missing data procedure for SO2. This is straight from the rule. SO2, CO2, moisture, and, well, that's it. Or for heat input determination. So if I'm in the 95th percentile, 95 or above, 95% available or above, and my data is only out for less than 24 hours, I get to use the average of the hour before and the hour after. So I just go grab before after, that's my average, I'm good to go. Now if it's greater than, I have to look at the average of the 90th percentile for these pollutants. And for these other pollutants, I look at the lesser of the 10th percentile. It's very clear, right? And then you get into even more, 90 and 95. So let's jump down to 80 because we can look through these and it's very, I mean, it tells you exactly what you have to go look at. So, but below 80, I don't, it doesn't matter how long I'm down as long as I'm down greater than 0. The maximum potential concentration or percent for these pollutants. So let's see, that's where you're starting to get, if you get low data availability, man, they make it painful. So there's, beyond even using some statistics, they're saying, well, we're just assuming that you're at maximum. So NOx considerations is load base is equal to units that produce electrical output in megawatts or thermal output in 1,000 pounds per hour of steam, and non-load based is everything else. So an operational bins is a procedure for defining the bins in Appendix C. The average emission rates are segmented based on operational conditions, electrical output, thermal output, types of fuel combusted, specific stages of an industrial process or heat input. If data needs to be substituted, use the corresponding operation rates to make that average substitution. So here is our NOx load-based substitution rules. So NOx varies a little bit from SO2 and the others. So, we can look, again, if you're 95 or more available in less than 24 hours, I get to use the average at 2,160 hours versus the 720. So you have to use a longer averaging period. And then again, if you jump down to the bottom, the maximum potential NOx emission rate or maximum potential NOx concentration or maximum potential flow. And it doesn't matter what period you're looking at because you're using max. So non-load based substitution rules. So this would be for if you were applicable on, I don't know, maybe a process heater or somehow you got into part 75. Very similar, but just not quite as many breakouts of what you have to look at. Other caveats, initial missing data. If you're just starting up a CEMS and need to data replace, there are more strict rules, but there is not, because you don't have historical 90th or 95th percentile. And then the 3-year rule, so when thinking about data monitoring, or about monitoring data availability and percentiles over a set period of time, we're talking about over hours of operation. The exception to that is you must never use data that is older than 3 years, which it actually defined clock hours there, so they aren't saying operational years, right? They're saying clock hours, to find the 90th percentile or to count towards monitor data availability, even if it falls within the amount of operating hours, 3 years, and it becomes too old. Is that clear? Multiple fuels. When running 2 separate fuels, separate averages and replace with the percentile that corresponds with the correct fuel. Co-fired, when substituting data while firing multiple fuels, there are 2 options. Either use the average of the fuel with the highest emissions or keep a co-fired average separate. And then add-on emission controls. There are more stringent requirements when it comes to data substitution with these units. Mainly, these requirements are to provide parametric data to verify the proper operation of the add-on emission controls. So just a little more stringent to help with the substitution. All right. I can pull up the exercise real quick and then we'll be done if nobody has any questions.
We've been asking a lot of questions about that.
how does that look on the screen? Okay.
You can read it.
Okay, so what I've got here is minute data, and so what I want to look at is your block, like what would be considered a good hour, what would be considered a bad hour, what would I have to throw out. So I'm looking at minute data starting on 11/20/2014 at midnight. So I've got CEMS readings, and then at 1300 or at 13 minutes into the night, my system just starts spitting out no good data, right? So I didn't put in a number, it just says, hey, I lost communications. So I gotta try to get this to where we can see the whole block here. All right, so I've got no good data for a stretch here. I'll put the count up. So let's see, I've got no good data for 18 blocks in a row. So that means I have to throw that out, right? I don't have any good data for 15 minutes. Do you agree?
No, because you gotta have one data point every quadrant.
I agree. So I'm looking at block 15-minute periods, right? So from 0 to 15, I had 1 point, and then at 31, I have a good point. So I don't have to throw, even though that's 15 consecutive 18 blocks, you're still good within that window.
You gotta look at it, it can hit each quadrant.
Okay, so then I moved down here further, and I still have a few throwing out data.
So how do you say that you had a data point from that quadrant? That would not be a valid hourly average under Part 75. Yeah, you
I'm in Part 60. I live in Part 60.
But from 15 to 30, you have no good data, and that's one full quadrant.
Oh, you're right.
But I guess the caveat would be too, if
You're right. You're right.
Because he does, it starts at 31, not 30.
But from 15 to 30, I didn't get anything. So you're right. Thank you.
unless you're performing maintenance, right, then you only have to have 2 good quadrants.
Right, depends on why it's not good data. That's
So my example just says no good data. But yes, I'm sorry, you're right. So from 15 to 30, I don't have a block, I don't have anything in that section. Yes. So you're right. So I get down here and I get into another chunk to where I have 16 consecutive datas, but it goes from 1700 to 3200. So there, even though I'm more than 15 minutes without data, I've got a point in both quadrants. Okay. That was all I had to look at.
Question, what's the difference between a calibration and a verification? And does a verification or
Typically,
same thing as substitution?
it's just, wait.
Because our guys say they do a verification, not a calibration.
So that's simply lingo.
So
I've
it's
heard
the
it.
same.
Verification,
So some people
calibration.
would consider it calibration. I'm actually adjusting the instrument
Yeah.
to calibrate it.
Yeah. Daily check.
Yeah.
I mean, you just have
Legally,
to.
it's the same.
Legally, as long as you're doing those things, like, whether they call it a verification, calibration, daily check. I mean, I've heard 10 different, lingos. As long as they're doing that, then they're good. You're good. You're meeting the intent of the rule. Doesn't matter what you call it. So real quick before everybody leaves, could I get a course evaluation?